All right, so today we're going to be diving deep into edge computing. You want to understand this tech. Well, we've got a whole bunch of sources here. Reports, articles, research papers, even some real-world examples.
Yeah, and what I find interesting about edge computing is that it's more than just, a tech buzzword. This has a real potential to completely change how we interact with technology every single day.
Absolutely, and that's exactly what we're going to try to uncover today. In the simplest terms, edge computing is kind of like bringing the processing power, closer to where the action is. Instead of sending all that data to a cloud, like far away, it's processed right there on the edge, close to the device,
So it's like having a mini data center.
Right
where you need it. Imagine if your refrigerator could analyze, your grocery habits, like what you buy and stuff, and then order the things you need directly from local suppliers.
That's a pretty cool thought.
Potentially saving money and, maybe even cutting down on delivery emissions.
Wow. That's just a glimpse. That's amazing. Okay, so before we, get ahead of ourselves, let's start with the basics. What exactly is edge computing, and how is it different from the cloud computing that we're all already using?
So think of it this way. Cloud computing is like ordering takeout. You're sending your request, your data, to a central location. Think of the restaurant, right? That's where it's processed and then delivered back to you, the food.
Okay, that makes sense.
Yeah.
So what would be the edge computing equivalent in that scenario?
Well, edge computing would be like having a fully equipped kitchen right there in your house. You have all the tools, the ingredients you need to process the data, to prepare the meal, without having to rely on like a distant restaurant.
Okay. So instead of sending my data on this long trip to the cloud and back, edge computing lets me process it right there on my device, or like a nearby local server, something like that.
Yes. And this idea of bringing processing power closer to the source, it's not completely new. Jörg-Owe, he's an expert in connected vehicle technology. He's been talking about this for a while, especially how it relates to, the automotive industry.
Oh, that makes sense because, a self-driving car needs to make decisions like in a split second.
Exactly.
It can't wait for, the data to go back and forth to the cloud. It needs the processing power right there, right on the edge.
Precisely. And so this need for that real-time processing, together with the explosion of all these devices connected to the internet, that's what's really driving the rapid growth of this whole edge computing thing. We're talking about everything, smartphones, fitness trackers, smart homes, industrial sensors, all these things generating massive amounts of data.
It's true. Think about all the devices in your own home, that are now connected to the internet. Your TV, your thermostat, even like your light bulbs. This whole network of connected devices, that's what we call the Internet of Things, or IoT. And it generates a ton of data.
Yeah, it does. And that's where edge computing comes in. By processing that data closer to the source, it can reduce latency, which is, the delay between a request and a response. It can also enhance security and even make those devices, more efficient.
Okay, so we've established that edge computing is basically about bringing processing power closer to the, data source.
Right.
But how does this architecture actually work? What are the building blocks of it?
So there are like 3 key layers to understand. First, you have the infrastructure layer, and that's basically the foundation. It's the hardware, the servers, the networks that make all of this edge computing possible.
It's like the physical infrastructure, right? The nuts and bolts.
Exactly. And then we've got the platform layer. And that one provides the tools and the services, that developers need to actually build and manage applications on the edge. It's kind of like a software framework that sits on top of the hardware.
Okay, I see. So the platform layer provides the tools. It's like the environment for building the applications, right?
Yeah, it's a good way to put it.
What's the third layer?
The third layer is the software layer. And that's where the applications, the ones that users actually interact with, that's where those live.
Okay.
And these applications can be anything, like data analytics tools or machine learning algorithms or even user interfaces for, controlling those smart devices that we talked about. It's kind of like, when you're building a house, the infrastructure is the foundation. The platform is like the frame, the walls, and then the software, that's like the furniture and, the appliances, all the stuff that makes it a home.
Yeah. I like that. That's a really good analogy. It helps to kind of visualize how those layers all fit together. So we've got the hardware, the platform, and the software. But where does the actual processing happen?
That's where these things called edge nodes come in. They're essentially mini data centers located really close to where the data is. That's where all the processing happens. Think of them as the brains of the operation.
So instead of sending all the data all the way to a central cloud, these edge nodes can process it right there on the spot.
Yep, exactly. And that's really what gives edge computing, well, it's edge, right? By processing that data locally, you can dramatically reduce latency, which is, the delay between when you make a request and get a response. So it makes everything way faster, more responsive.
You've mentioned latency a couple times now. Can you explain, like for those of us who aren't, tech experts, why is that such a big deal?
Okay, so latency is the delay between, like I said, when you make a request and then you get that response. And just think about, when you're playing an online game, right?
Yeah.
And there's that lag. It's so frustrating, But in some situations, it can be way more than just annoying. It can actually be dangerous.
Oh, yeah, that's true.
Yeah.
You have a self-driving car, for example. Relying on data to avoid an accident, any little delay could be, well, really bad.
Exactly. And it's not just self-driving cars. You think about remote surgery, where the surgeon is controlling the robotic arm from, miles away. Even just a millisecond of delay could be super critical.
Wow. So edge computing is not just about speed, it's also about safety and reliability.
For sure. And there's more. Edge computing can also really improve security, because the data's processed locally. It's not as vulnerable to, being intercepted as it's being transmitted, which is especially important for sensitive information, right? Like your financial transactions, medical records.
Makes sense, yeah. Like having a security guard right there at the entrance instead of relying on someone who's miles away.
Precisely. And because it's reducing the amount of data that actually needs to be sent to the cloud, edge computing can also help to optimize how we use bandwidth. This could lead to, well, potentially faster internet speeds and lower costs for everyone, the providers and the people using it.
Okay, so faster processing, you get enhanced security, optimized bandwidth. It sounds like a win-win. Any other benefits we should know about?
Oh, absolutely. Cost efficiency. It's a big one. By processing the data locally, businesses, they can reduce their reliance on that expensive cloud infrastructure. And because edge computing is super scalable, companies can easily add or remove edge nodes as they need to.
So it's like a flexible solution. It can adapt to like the changing needs of businesses. Makes sense. Yeah. But let's be real. There got to be some challenges too, right? It can't all be perfect.
Yeah, you're right. Edge computing is, well, it's like any technology, It comes with its own set of challenges. One of the biggest ones is, well, it's network reliability. For edge computing to really work smoothly, you need really stable and robust connections between all the devices and those edge nodes.
I can see how that could be a problem. Especially in places with like spotty internet coverage. What happens if an edge node loses its connection?
That's a really good question. It kind of highlights how important data management and validation are. Even though data is being processed locally, we still need to make sure it's accurate, make sure it's all good, What if a sensor, it malfunctions or it sends data that's corrupted somehow? We need, really solid systems in place to deal with those kinds of things.
It's not just about processing power then, right? It's about the quality of the data. And making sure that, well, that the whole system is reliable.
You got it. And we can't forget security either. With more devices connected and data being processed in all these different places, the attack surface for hackers, it gets much bigger, So securing all those edge nodes and the data that they handle is super important.
It's like having multiple entry points into a fortress.
Yeah.
Right? You got to be on guard all the time.
Exactly. And then you've got the issue of spectrum allocation, which is, all about managing those radio frequencies that are used for communication between the devices. With the huge growth of connected devices, the demand for spectrum, it's just going up, 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 which can lead to bottlenecks.
Yeah.
Interference.
So like rush hour traffic, but for data instead of cars.
Yeah. And experts, like Jörg-Owe, they're really looking into ways to optimize that whole spectrum allocation thing, especially when it comes to connected vehicles and smart cities.
Okay, so network reliability, data management, security, and then spectrum allocation. These are big challenges. But even with all that, edge computing it's gaining a lot of traction. What's driving this adoption, and what are some of the things we should be watching for in the future?
Well, one of the main drivers is that there's just more and more demand for real-time applications, especially in industries like manufacturing, healthcare, transportation. And as 5G networks become, more common, edge computing is going to get even more powerful, even more versatile.
So 5G is like the fuel that powers the edge computing engine.
That's a good way to put it, yeah. And we're also seeing more and more focus on something called quality of service optimization. Researchers are always trying to find ways to improve things like latency, network availability, and even task offloading strategies, which is where, you shift some of the processing tasks between the edge and the cloud as needed.
So it's about finding the right balance between edge computing and cloud computing, right?
Yeah.
Depending on what you're trying to do, what the requirements are.
Exactly. And that actually brings us to another exciting development. The integration of edge computing with, artificial intelligence. AI. By processing data locally, AI algorithms, they can make decisions in real time without having to connect to the cloud.
So all our devices are going to get even smarter, more autonomous because of this combination of edge computing and AI.
Exactly. Like personalized healthcare recommendations, smart traffic management, even robots that can learn and adapt to their surroundings. It's amazing what could be possible with this, with edge AI.
Yeah, it really does feel like we're stepping into the future. But with all this data being generated, and processed at the edge, how do we make sure it's all handled responsibly? What about privacy? I mean, that's a big concern.
That's a really important point, and it's something that everyone's thinking about, The researchers, the developers, everyone's taking privacy and security very seriously in this whole edge computing world.
So how do we balance, how do we get the benefits of edge computing but also protect our personal information?
Well, one way is to use techniques like, what's it called? Differential privacy. That's where you add noise to the data to protect people's identities. But you can still do meaningful analysis with it, and by processing data locally, we can limit how much information actually has to be sent to the cloud.
Yeah.
That reduces the risk of it, being exposed.
So it's about making that data footprint smaller.
Right.
And protecting all that sensitive information.
Exactly. And it's not just about, the tech itself. It's also about setting up clear guidelines, regulations for how data is collected, how it's used, and how it's shared, in an edge computing environment.
Yeah, that makes sense.
No.
We need those safeguards to make sure this technology is being used responsibly and ethically.
Absolutely. And as edge computing keeps growing, I think we're going to see more and more companies popping up offering it as a service, Just like we have all those cloud service providers now. This will make it way easier for businesses, all sizes, to use edge computing without having to build their own infrastructure and all that.
So they could just rent edge computing resources, basically, on demand, kind of like how they use cloud services now.
Exactly. And the last thing to think about is, the strategic distribution of those computing resources. It's not about, moving everything to the edge. It's about finding that right balance, between edge computing, the cloud, and even processing on the device itself. It all depends on what you're using it for.
So we need to create a hybrid ecosystem where the data is processed in the best way possible, efficient and secure.
Precisely. And people like Jörg-Owe, they're really leading the way here. They're trying to figure out how to optimize those hybrid architectures for all sorts of different use cases, especially, in the automotive world.
Wow. Well, this has been a really great conversation. Lots of information to think about. Before we wrap up, can we summarize some of the key takeaways for our listeners?
Sure. We started by defining edge computing. What it is, how it's different from cloud computing. We talked about the benefits. Reduced latency, better security, cost efficiency.
Yeah, and we also talked about the 3 layers of the edge computing architecture, the role of those edge nodes, and, how important things like network reliability, data management, and security are.
Right. And then we went into those challenges with spectrum allocation, especially with 5G and the Internet of Things. And of course, we had to touch on all the exciting possibilities of edge computing, especially when you combine it with AI.
And we also mentioned the ethical stuff, the need for responsible data management in this whole edge computing world.
As edge computing evolves, it's really going to transform how we live, how we work, how we interact with technology. It's an amazing field, and I encourage everyone to, learn more about it.
I agree. It's been a really insightful deep dive into edge computing. It's clear that this technology has the potential to change so many things about our lives.
For sure. As we move into this world where everything's connected, understanding edge computing is going to be so important for anyone who wants to, stay ahead of the curve.
That's a great point to end on. Well, that wraps up another deep dive. Thanks for joining us. And until next time, keep those brains buzzing.